Hey everyone, Dan here bringing you the next installment in our series of guided review questions. Today we're taking a look at problem 5 from the review questions in this module. And the problem reads, carbon reacts with water vapor at elevated temperatures. We're given an equation, carbon solid plus H2O gas goes to carbon monoxide gas and H2. And we're told that the equilibrium constant, K sub C, equals 0.2 at 1000 degrees Celsius. So what we want to do is find the concentration of carbon monoxide in the equilibrium mixture when the concentration of H2O equals 0.500 molar, again at 1000 degrees Celsius. So we're given a little hint at the end of this. Assume that carbon monoxide concentration equals the H2 concentration, which equals X because they're produced in a 1-to-1 ratio. So the first thing to remember is that a K sub C expression is of this form, where you have the concentration of the products raised to some power over the concentrations of the reactants raised to some power. And where those powers are going to come from is the balanced chemical equation. So in this case, we were nice and we gave you a balanced chemical equation. You should always check, though, to make sure that it is in fact balanced, because if you don't, you're not going to have the right exponents in your equilibrium expression. All right, so if I substitute in the products and reactants for this reaction, notice I have the concentration of carbon monoxide, my first product, to the first power, because we have a coefficient of 1 for carbon monoxide, times the concentration of H2, my second product, also raised to the first power, because we have a coefficient of 1, divided by the concentration of H2O to the first power. Notice that we've omitted carbon from the K sub C expression because it is a solid. So any condensed phases, like solids or liquids, will be omitted from the K sub C expression. Or if you want to include them, you would insert a 1. So you would just be multiplying or dividing by 1. So it's easier to just omit them. All right, so we have our K sub C expression. I would recommend using this as an intermediate step. Don't just go ahead and substitute numbers in, because it's easy to misplace them. So if you actually write this out each time, you'll know exactly where you're going to plug in numbers. Speaking of which, we're told to let the carbon monoxide concentration and H2 concentration both equal X. So when we substitute into this expression, notice we're going to have X times X divided by the concentration of water, which in this case is 0.500, and all of that is going to be equal to the equilibrium constant, which in this reaction is 0.2. So if I go and solve for X, my first step is going to be to multiply both sides by 0.5, and we wind up with this. Notice I've condensed the X times X into X squared, because in the next step I'm going to take the square root. So when I take the square root, notice I'm going to get X by itself. So X is going to equal the square root of 0.2 times 0.5, and again X equals the concentration of both H2 and carbon monoxide. So when I throw this in the calculator, I get a value of 0.316 molar. Notice that I am including units here because we're solving for concentrations. If we were solving for a K sub C or a Q sub C, those are in fact unitless, as evidenced by up here. There were no units on this. But if you are solving for a concentration, you do want to include whatever units are appropriate. So in this case, we have units of molar, and down here I will also use molar. You may have noticed that the K sub C was given with only 1 sig fig, so technically it would not be incorrect to report this to 1 sig fig, so that would just be 0.3 molar. Remember that that leading zero is insignificant, so it's only your first non-zero digit and then the rest. So 0.3 would be 1 sig fig. I think the author of the question intended for it to be reported to 3 sig figs because they gave the concentration of H2O with 3 sig figs, but technically you can get away with just writing 1. All right, I think that's everything. If you have any questions about how I solved this, or want to see similar problems, or have just any questions in general, you can attend our online office hours or email anyone on the teaching team. I think that's everything. So thanks for coming to my TED Talk. Catch you in the next one.